All right, let's go ahead and solve this equation for number 4, for example 4. Now I'm going to be honest with you, even though it's right in the title, it says, hey, let's use some identities to solve this. It took me a while on this one to figure out which identities to plug in and where. So it is okay to have to struggle a bit and try to find something to work sometimes. So what I noticed right off the bat is we have two different functions. So what I said, let's go ahead and make my equation equal to 0. So I added 5 to both sides and I said it was 0. Now I tried a couple different things before it finally dawned on me. What I was trying to do is link the cotangent squared. Do I have an identity that will let me put cotangent squared with cosecant? And the answer was sort of. So what I'm going to do is what I eventually ended up doing, and I think it works nicely, is replace cotangent squared theta with cosecant squared theta minus 1. So what I'm going to do is I'm going to take this out of my equation and I am going to put this in its place. So let's do that. Cosecant squared theta minus 1, that is the entire cotangent squared theta right there. And we can subtract 4 cosecant squared theta plus 5, and that equals 0. We can combine the -1 and the +3. So cosecant squared theta minus 4 cosecant theta plus 4 equals 0. Can I factor this? Are there any factors of 4 that add to -4? Yeah. -2 and -2. So we can factor it to say cosecant theta, that's my x, minus 2. Cosecant theta minus 2. And that equals 0. If you're not seeing the factoring, how I treated it was like this. I said, what two numbers multiply to give me +4 that add to give me -4? These are ready to solve. So cosecant theta is going to equal 2. You know what? I'm doing a shortcut. Let's not do shortcuts, shall we? Subtract 2 equals 0. So cosecant theta equals 2. So we're going to take the inverse of the cosecant theta. We're taking the inverse of cosecant of 2 to find theta. There we go. To find the inverse of cosecant, we're going to do the inverse of sine, but write that as the reciprocal. So on our unit circle, where is sine +1/2? And it's right here at pi/6. If my reference angle is pi/6 there, it's going to be the same here. So this is going to be pi minus pi/6, which is going to be 5pi/6. So the two values of theta that I got are pi/6 and 5pi/6. Now if you look at your instructions though, the instructions said list all of the solutions. Not just these two, all of them. So we're going to say pi/6 plus 2n pi. Add a full rotation, that pi/6. And 5pi/6 plus 2n pi, where n is an integer. And that'll be all of my values of theta for this equation. Now here's some tricks and hints to help us solve these. So look at the form. Is it linear? Is it just one is it one trig function? Or are there a couple? Is it a square in there? That's the quadratic. If we only have one trig function present, first solve the equation for that function, and then use your inverse trig function. If we have more than one trigonometric function, rearrange the equation so that one side equals 0. Factor it. If the equation is in quadratic form but not factorable, use a quadratic formula. Check, make sure our solutions are in our desired interval. And try using identities to change the form of the equation. So it might be helpful to square each side of our equation first. If that happens, check for extraneous solutions. And I'd always tell you to check your solutions against your graphing utility. Graph the equation and see if it gets the answers you want on the x-intercepts. Okay, the x-intercepts should be my solutions. All right. Oh, and try something. Please don't just, if at first you're struggling, don't give up. Try something new. Let's do number 5. Well, let's cover 5 together in class. And then let's do number 6. So we just want one rotation of our circle. Again, this one gave me a little bit of trouble. I had to work with this for a bit, but then I realized, hey, wait a minute. Let's try this. It already equals 0. I have two different functions. So why don't I take tangent of theta, and let's change cotangent into 1 over tangent theta, and that's going to equal 0. Now this doesn't factor. That doesn't factor, but what I can do is I can multiply everything by tangent theta. Now that we're the same terms, multiply everything. I'm going to take this equation and I'm going to multiply every part by tangent theta. And what that's going to give me, it's going to give me a tangent squared theta minus, I'm going to write this out so we see it, tangent theta over tangent theta. And 0 times tangent theta is still 0. So then we're left, if we keep working with this, simplify it. Tangent theta over tangent theta is 1. Add 1 to both sides. Square root both sides so I can get tangent theta by itself. And when I square root both sides, remember I got to do the plus or minus. If I'm taking the square root of the tangent squared theta, and then I'm going to take the square root of 1, we always put that plus or minus inside, or in front of it, because -1 times -1 is also that. So we know inverse tangent of 1, -1, is going to equal theta, and inverse tangent of 1 will also equal theta. So what we want from this, what we want from this is, where is tangent going to give me a -1 value? So when we look at our unit circle, tangent gives me a value of 1 when y and x are the same, and that's going to be radical 2 over 2 and radical 2 over 2. And that happens, we're in radians, and that happens with the reference angle of pi over 4. Well, it's -1 on this side with my reference angle of pi over 4, which would make this 3 pi over 4 because tangent is negative in this quadrant. Now what we're going to find is it's these two values, but we keep adding pi. Tangent is on an interval of pi instead of 2 pi. So we're going to say pi over 4 plus pi n and 3 pi over 4 plus n pi or pi n, where n is an integer. Goodness, I can't write. And it's pi now instead of 2 pi because tangent is on a pi period. If you remember that, the period of tangent is pi. We're going to do 5 in class, like I already said. Let's go ahead and we're also going to do 7 in class. Or you can give 7 a shot on your own. Come into class, and if you got any questions, let me know. I'll definitely go over this with you. And if you got any questions at all, just let me know, and I'll be glad to help out. I'll see you in class.